Hi everyone, my name is Sahar Halim and I am presenting my Capstone 3 project, which is predicting Alzheimer's disease using machine learning. And the goal of this project is to predict whether the patient has Alzheimer's disease or not. And the tool I'm using here is Machine Learning Studio. It is a no-code, low-code tool where you can build machine learning pipelines by dragging and connecting modules. The ML technique that I am using here is supervised learning, and in supervised learning, I am using classification module. I've acquired data from Kaggle, uploaded by Rabi Al Farouk. And the target column here is diagnosis, which will tell us whether the final result is it will tell us that the result is Alzheimer's or not in a patient. There are other features to consider as well. For example, age, MMSE score, which is mental test score, which is very important because our age and gender and MMSE score also helps in making the helps the model make better prediction. For example, if someone has a low mental test score, MMSE score, and high age, the model might learn that this is more likely to mean that the patient has Alzheimer's. So the step-by-step pipeline that I've worked with is first load the data, visualize it to see if it needs cleaning or if there are any missing values. Then mark categorical variables, see what categories are important for the predictions. Apply one-hot encoding. Then normalizing the features, numbers, splitting data into training data and testing data, and then training the modules. And then last but not least, comparing the performance. Here, since I am using two classification models, logistic regression and boosted decision tree. So the last step would be to compare the performance between the two in order to select the best model. The first step is load and visualize data set. We will first import the data. We import data by uploading the CSV file, and we will then use dataset module through which we can also visualize our data to check for missing or inconsistent values. Then comes our second step, which is pre-processing. And in this module, in this step, we will fix the issues like categorical columns, as your ML needs you to explicitly say which columns are categories like gender and age, living arrangement or ethnicity, etc. So for that, we will use edit metadata module. Then another issue could be one-hot encoding. It's not exactly an issue, it is a fix that will, for the issue, like, for example, what happens is that sometimes our model may predict higher value as a better value than the lower value. For example, we have 2 and 8 since 2 is lower than 8, our model may predict that 2 is not exactly a good value to be considered. So in order to avoid that, we use one-hot encoding. Here, according to our model, we need that for gender. For we have 2 types of gender, male and female. We do not want our model to think that male is better than female or the female is better than male. For example, male may have more likeness to get Alzheimer's than females or something. So this is not exactly the metric that we want our model to consider in order to tell whether the patient has Alzheimer's or not. So that for that, we will use one-hot encoding. And what it will do is that it will turn the gender column into 2 columns, gender male and gender female. So convert to indicator values is basically that module which performs one-hot encoding. Then normalization of the data. Here we scale numbers like age or MMSE, mental test score, so that one does not overpower the other in the module. Again, we want to make sure that all our values contribute equally in the prediction of the better results. Next step is data splitting. So next step is data splitting, and here, sorry. Here we are splitting the data into 2 parts, training data and testing data. Training data is where the model learns the patterns of our scores, of our predictions. And the testing data is used for the module used by the module to evaluate the results on a new data that it hasn't seen before. So the next step would be model training. In this module, in this step, we will, I have tried 2 types of models. Logistic regression, which is a simple model for binary classification, and a 2-class boosted decision tree, which is more powerful than logistic regression, and it is very good for medium to large data sets. Logistic regression, on the other hand, is very good for the smaller data sets, but not very good for the medium or large data sets. So here we have used train model module and set diagnosis as the label column. What is the label column? It is the result column, the final result that we want to achieve. So we set one of the columns as a label column. And the next step is the scoring and evaluation. In this column, in this step, we will use score model to test model predictions. So score model, what score model does is it uses the metrics, different metrics, to test our predictions, test model predictions, and then the output is sent to the evaluate model, and that model uses the metrics, which is accuracy. Accuracy is how often it was the prediction, how often the prediction was right. Precision, how many predicted Alzheimer's cases were correct. Recall, did you catch all Alzheimer's cases? And AUC, area under curve, a good overall performance measure for classification, this is a good overall performance measure for classification. The next would be the comparison between the two models. As we can see here, the left port was connected by the boosted decision tree model, and the right port was connected by the logistic regression model. And even if there isn't that much difference in the score, but since we are trying to select the best model possible between the two, so we will choose boosted decision tree because it is giving us the accuracy level is higher in this model than the logistic regression. It is, as we can see, the accuracy is 0.942 here, and here in the logistic regression it's 0.833. The precision is 0.927 here, and here it is 0.791, and so on and so forth. We also see that which model is better at distinguishing between positive or negative classes. That's why we have chosen boosted decision tree as the final model. So in conclusion, Azure ML Studio makes ML projects visually intuitive, and it's very easy for beginners to learn. We can see from this project, that I have noticed from this project, is that pre-processing matters a lot, and I mean a lot. Labeling the data correctly is very, very critical, because this is the step which will decide how good our model is going to perform. So this is a very crucial step in our pipeline. And as we can see, as we've seen in the evaluation before, the boosted decision tree works well on this data, better than logistic regression. And these are the two models that we were using, and we connected them with our evaluate model. So the next steps that I am going to try is I will try bigger data sets, since I know that boosted decision trees work well with the bigger data sets as well. I would definitely explore neural networks, how this goal will be achieved through neural networks, and how good it is going to be. And I would really like to deploy my model as a web service for hospitals or clinics so that they can use it in real time. So that's it. And that's my time for today.